Yeah, it's a whole couple of lessons actually. It's after that. Once you accept it, just straight away. You have to accept, not fail the classes, so you're working through it. Okay, so you can make it. So that's okay, if you were not here yesterday in class, we just practiced some factoring problems. So is anybody who wasn't here yesterday? Okay, you don't have to finish this. Even yesterday, I just said it's classwork, not homework. So we're gonna go over the answers. We'll try to work on it during that time. But we don't have to go through finish all this or make it work or anything. Did anybody else not get this yesterday? Okay, so there's something like tricky about these. First off, they all have A greater than 1. So according to what we did yesterday, there would be problems like on the right side where you have to do the A times C method. So I did put on here, consider a possible shortcut. There's something really special about these three problems that makes them a little bit different than the ones we did yesterday. Okay, so there is a shortcut for these three that did not exist in the problems yesterday. So for these, there are two methods of solving. Okay, the first is the A times C method. So we might as well go ahead and do it. But it's the thing about it is that the numbers are so big. Like 25 times 49. Everybody get your calculators out. Okay. Is 1,225. So we have to list numbers that multiply to 1,225 and add to negative 70. So that's going to take a really long time. So I'm glad there's a shortcut. I'm going to go through the long way, but then I'm going to show you a shortcut. I guess I would start with dividing by 5. So we could do negative 5 times negative 245. And then maybe I would try 50. That doesn't work. Maybe I try 15. That doesn't work. Well, we know it divides by 7 because we used a 49 to get there. So maybe I'll try 7. We could do negative 7 times negative 175. Oh, maybe it divides by 25? Negative 25 times, oh yeah, I already have that there. That doesn't make 70 though. Oh, maybe 14. No? Maybe 21? No? 75? No? Oh, do you have it? Okay, don't give it away yet. We're thinking about it. One person has it. Who else has it? Three people have it. 4 people have it. Okay, I still have it. Huh. Oh, 1 maybe. So, keep looking at your numbers, keep thinking about, so I'm thinking about all of the factors of 49, so that's why I tried 7. Factors of 5, try 5. You know what, maybe we should try 35. 7 and 5 make 35. Does it divide by 35? Negative 35 times negative 35, 1,225. And negative 35 minus 35 equals negative 70. So those are our numbers. Okay, so when the numbers are large, it takes a longer list, more problem solving. It really helps to have a calculator out. After you pick your numbers, you go back to the original problem and you write the numbers you picked right in the middle and you factor by grouping. So I'm gonna pause and let you guys do the GCF for a moment before I finish it. So take the greatest common factor out of the first two and the second two. Oh, these should both be minus, y'all. Minus 35x minus 35x. So that's because it's a negative 70. I can't wait to do the shortcut. You're gonna love it. So I think about what number 25 and 35 both divide by. They both divide by 5 and they both have an x in it, just the first two. 25 divided by 5 is 5. It was x squared, but we're factoring 1x to the front, so 1x left over. 35 divided by 5 is 7. Questions on that group? Alright, we'll look at these two. What do 35 and 49 both divide by? 7. When the third number is negative, take a negative GCF. So we're going to factor out a negative 7. Negative 35 divided by negative 7 is a positive 5x minus 7. The last step to factoring is to put the GCFs together and keep one of the matching sets. And it happens to be that these are the same. So you could write this, whenever they're the same like that, you can write it with a little power too. So if you weren't here yesterday, this was done on the Friday before we were out. There's steps on this handout. I don't know if this looks familiar. So there's a video from the Friday before we were out. There's a video from yesterday that goes over this process. So, All right, now what's the shortcut? So the ones we did yesterday don't have any shortcut, but all of these three do. What is special about these numbers? There's a lot of one certain type of problem. Yeah, you can take the square root. There's a lot of numbers up here that square root. Okay, so if you can recognize that, that's a good indicator that there might be a quicker way to do these. 25 and 49 both square root. 9 and 64 can be square rooted. And 36 and 25 can be square rooted. So these are our special problems. They have their own special name. Number one's called a perfect square trinomial. So let's look at the second way to do number one. We got 25x squared minus 70x plus 49. So instead of doing all that, you can just go straight to parentheses and you can square root. So square root of 25. That's 5x, and I put that in the first spot for both parentheses. 5x, 5x. And then you square root 49, it goes in the second spot. Square root of 49 is 7. And then you always keep the sign in the middle. And then it's done. It's the same thing, so you write it 5x minus 7 squared. So the numbers that ended up working out when we did that whole process were the square roots of 25 and 49. So it's always like a really satisfying moment when you see perfect squares and you have to factor because you're like, oh, shortcut, yes. Yeah, now there's a little rule involved. And it has to do with the 70 here, because everybody wants to know, like, well, what about the 70? The 70 doesn't square root. What about the 70? So the rule about the 70 is called B. B must be twice the product of the square roots. And it almost always is, unless they're tricking you. So this isn't a coincidence, it's a rule. 5 times 7 is 35. 35 doubled is 70. So there's 3 patterns there. 5 times 7 is 35. 35 doubled is 70. So we got square roots here, and this is double the square roots. So, and maybe you don't totally buy into that right now. You should check it, like we talked about yesterday. You can always check it if you think maybe it is square roots. Just take a minute and write out the square roots that you came up with and the sign you came up with. And do your FOIL. So 5 times 5 is 25x squared, yep. 5 times negative 7, negative 35x, minus 35x, plus 49. 25x squared minus 70x plus 49. Checks right out. So if you have numbers that can square root, the quicker way is just to use the square roots and then maybe FOIL it and check it instead of doing the long A times C process. So y'all try number 2 now, using the square roots. So method 1, if you can figure it out, always works on any of them. Method 2 will work if the number is square root. So it's a welcome shortcut, just a long the square root of that one.
Oh, so we have to figure this out first.
Yeah, square root of this. No, this is the original problem. The square root of this one goes first, and then the square root of that one.
Oh, you just write it twice.
Yeah, just write it twice. Alright, so number 2 is another example of what we can call a perfect square trinomial. This is a kind of a really important pattern to recognize in higher math because mathematicians will just square things left and right in order to be able to factor this way. So they do it with trig functions and curves and things like that. So this pattern carries on for a long time. Uh-huh. No. The reason I made it negative was because of the sign here. Okay. So this will always be positive if it works. And then if that's negative, then both of them are negative. No, because the 25 is positive. Okay, so because I know the square root of 9 is 3, I'll go ahead and put 3x in both of my factors. And the square root of 64 is 8. I'll put 8 in both of them. Now this entire thing is positive, so I definitely don't want any minus signs in this. Everything's positive. That's done. That's factor. If it said factor and solve, I would just set this equal to 0, minus 8 divided by 3, and then I would have the root. Maybe I want to check the rule. The rule would be that the middle must be 3 times 8, which is 24, doubled. And that's 48. And the middle is 48. So, and if you don't want to think about the rule, you can just check it, boil it out, and see that it works. Any questions on 2? Square rooting. All right. Now, what's different about number 3? B is 0. Doesn't have a B in there. So we have square roots, but that rule, how do I check the rule? How do we not have a B? How does that work? Over here. You guys should be thinking about it. Try different signs. Try square rooting. Try checking. You know, you exploring that yourself is a little more beneficial than just copying what I write. Number 3 has a slightly different name. Instead of being called a trinomial, these are trinomials because there's 3 terms. This one's only a binomial. So this one's called a difference of 2 squares. It's 2 perfect squares. And the word difference is in there because it's subtraction. But you can still use the square root. So, I'll have the outside equal to. So I got my parentheses. I'll square root 36 and get 6x. Square root 25 and get 5. And then I have to figure out what signs should I use here with these square roots. Now if we make them both negative, we'd probably have a negative 60x in the middle. If we make them both positive, we'll have a positive 60x in the middle. What can we do here that would have the effect of getting rid of a b? Positive and negative. What we want is opposites in the middle of this problem. So we're going to use both sides with a difference of 2 squares. And I don't require you to check, but honestly, if we were, you know, really in the mood to work hard, everyone should check all of these because it would help you learn it. It would help you learn it better. So I'm going to check it here. I keep checking them, but you guys should really check them too. 6 times 6 is 36x squared. 6 times 5 be negative 30. Now positive 5 times 6 is a positive 30x. And a positive times a negative would be a negative 25. And what's happened in the middle, because we used a plus and a minus sign, in the middle, these two things cancel out. They're perfect opposites. Created opposite b's in there. And that's where the two terms comes from, is because these opposite signs ends up creating opposite terms in the middle. Cancel out. So, long story short, if you see numbers that can square root, consider using the shortcut. Just using the square root to get there. Alright, let's take some time and go over the answers to the handout from yesterday. See which ones you did and what questions you have. Alright, here's the answers to the left side. Here's number 17 on the right. You guys are not required to write all these down right now. It's not like that. But you should see if you can know how to do it. Whatever you did in class is fine. Now on the right side, I'm going to take some volunteers to come up and do some problems. There's 11 and 12. Even if you didn't do them yesterday, you can come up and do them now. Here's 13.